using a modular approach in network design. This section expands on the Cisco Service-Oriented Network Architecture, or the SONA framework, described in applying a methodology to a design video, and explores the 6 modules of the Cisco Enterprise Architecture, with an emphasis on the network infrastructure design considerations. Now, the modularity built into the architecture allows flexibility in network design and facilitates implementation and troubleshooting. Let's start with the Cisco-oriented network architecture, or the SONA. So as illustrated here in the figure, the Cisco SONA provides an enterprise-wide framework that integrates the entire network. So that includes the campus, data center, enterprise edge, WAN branches, and teleworkers. So that offering staff secure access to the tools, processes, and service they require. Now, the modules of the Cisco Enterprise Architecture represent focused views on each of the places in the network described in the SONA framework. So each module has a distinct network infrastructure and distinct services. Network applications extend between the modules. So let's talk about the Cisco Enterprise Architecture. So the functional areas of the Cisco Enterprise Architecture. So at the first layer of the modularity in the Cisco Enterprise Architecture, the entire network is divided into functional components. So functional areas that contain network modules while still maintaining the hierarchical concept of the core, distribution, and access layers with the network. Okay, so take note that the access, distribution, and core layers can appear in any functional area or module of the Cisco Enterprise Architecture. So the Cisco Enterprise Architecture comprises of the following 6 major functional areas, also called as modules. Okay, so this includes the enterprise campus, the enterprise edge, the service provider. Okay, so service provider 1 in the internet here. You also have the enterprise branch, the enterprise data center, and the enterprise teleworker. So the figure illustrates the modules within the Cisco Enterprise Architecture. Now, the key point here is an enterprise does not implement the modules in the service provider functional area. They are necessary for enabling communication with the other networks. So the Cisco Enterprise Campus Architecture combines a core infrastructure of intelligent switching and routing with tightly integrated productivity enhancing technologies, including mobility and advanced security. So the architecture provides the enterprise with high availability through a resilient multi-layer design, redundant hardware and software features, and automatic procedures for a configuring network path when failure occurs. So also, you've got the IP multicast capabilities provide optimized bandwidth consumption, and the quality of service features ensure that real-time traffic, such as voice, video, or critical data, is not dropped or delayed. So integrated security protects against and mitigates the impact of worms, viruses, and other attacks on the network, including the switch port level. So for example, the Cisco enterprise-wide architecture extends support for security standards such as the IEEE 802.1x port-based network access control standard and the Extensible Authentication Protocol, or EAP. It also provides the flexibility to add Internet Protocol Security, or IPsec, and MPLS Virtual Private Networks, VPN, identify and access management, and VLANs to compartmentalize access. These features help improve performance and security while decreasing costs. Okay, now let's talk about the Cisco Enterprise Edge architecture here. It offers connectivity to voice, okay, video, and data services outside the enterprise. Now, this module enables the enterprise to use the internet and partner resources and provides resources for each customers. So quality of service, service levels, and security are the main issues in the enterprise edge. Okay, so next would be the Cisco Enterprise WAN and MAN and site-to-site VPN module, which is also part of the enterprise edge. Okay, now it offers the convergence of voice, video, and data services over a single communications or over a single network, which enables the enterprise to span a large geographic areas in cost-effective manner. So the quality of service, granular service levels, and comprehensive encryption options help ensure the secure delivery of high-quality corporate voice, video, and data resources to all the corporate sites, enabling staff to work productively and efficiently whenever they are located. Okay, so security is provided with multi-service VPNs, both IPsec and MPLS. Okay, that is over a layer 2 or a layer 3 wide area networks, hub and spoke or full mesh topologies. You also have the Cisco Enterprise Data Center, okay, or the Enterprise Data Center architecture. This is a cohesive, adaptive network architecture that supports requirements for consolidation, business continuance, and security while enabling emerging service-oriented architectures, virtualization, and on-demand computing. Now, staff, suppliers, and customers can be provided with secure access to applications and resources, simplifying and streamlining management and significantly reducing the overhead. So redundant data centers provide backup using synchronous and asynchronous data and application replication, which is very important in the design. The network and devices offer server and application load balancing to maximize performance. So this architecture allows the enterprise to scale without a major changes in the infrastructure or to the infrastructure. So this module can be located either at the campus as a server farm or at a remote facility. Okay, so the next one would be the Cisco Enterprise Branch architecture. So this allows enterprises to extend head office applications and services such as security, okay, communications, and advanced application performance to thousands of remote locations and users or to a small group of branches. So it integrates security, switching, network analysis, caching, and converged voice and video services into a series of integrated service routers or ISRs that is located in the branch so that the enterprises can deploy new services without buying new routers. So the architecture provides secure access to voice, mission-critical data, and video applications anywhere, anytime. So advanced routing, VPNs, redundant WAN links, application content caching, and local IP telephony processing features are available with high levels of resilience for all the branch offices. So an optimized network leverages the WAN and LAN to reduce traffic and save bandwidth and operational expenses. So the enterprise can easily support branch offices with the capability to centrally configure, monitor, and manage devices located at the remote sites. Okay, So the next one would be this enterprise teleworker architecture here. Okay, so which allows enterprises to securely deliver voice and data services to remote small or home offices, known as a small office, home office, or SOHO, over a standard broadband access service, providing a business resiliency solution for the enterprise and a flexible work environment for employees. So centralized management minimizes the IT support costs and robust integrated services of security, which mitigates the unique security challenges of this environment. So integrated security and identity-based networking services enable the enterprise to extend campus security policies to the teleworker. So teleworker are those working away from the office, okay, working away from the enterprise. Okay, so these are working at home, okay, or work from home application. Okay, so the staff can securely log in to the network over an always on VPN and access or gain access to authorized applications and services from a single cost-effective platform. So productivity can be further enhanced by adding an IP phone, okay, so thereby providing cost-effective access to centralized IP communications with voice and unified messaging services. So this architecture allows the network designer to focus on only a selected module and its functions. So designers can describe each network application and service on a peer module basis and validate each as part of the complete enterprise network design. So modules can be added to achieve scalability if necessary. For example, an organization can add more enterprise campus, okay, if it has more than one campus. Let's have an example here of dividing the network into areas. So the figure shows an example of dividing network into an enterprise campus area, an enterprise campus edge, and some remote areas. Enterprise Campus Infrastructure Module. So the following section provide additional details about each of the functional areas and their modules. Okay, so let's start with the Enterprise Campus modules. So this section introduces the Enterprise Campus functional area and describes the purpose of each module therein. It also discusses connections with other modules. Okay, so an enterprise campus site is a large site that is often the corporate headquarters or a major office. So regional offices, SOHOs, and mobile workers might have to connect to the central campus for data and information. So as illustrated here, the enterprise campus functional area includes the campus infrastructure module and typically a server farm module. Okay. Now let's dig into the campus infrastructure module. All right. So the campus infrastructure module design consists of several buildings connected across a campus core. So the campus infrastructure module connects devices within a campus to the server farm, okay, across the campus core. Okay, so that is basically a single building in a campus infrastructure design contains a building access layer and a building distribution layer. Okay, so when more buildings are added to the campus infrastructure, a backbone or campus core layer is added between buildings. So the campus infrastructure module includes 3 layers. Okay, so basically, you've got the building access layer, you've got the building distribution layer, and you've got the campus core layer. So take note that in most general model, the building access layer uses layer 2 switching, and the building distribution layer uses layer 3 switching or the multi-layer switching. Building access layer. So the building access layer located within a campus building aggregates end users from different work groups and provides uplinks to the building distribution layer. So it contains end user devices such as workstations, IP phones. You also have network printers connected to layer 2 access switches, VLANs. Okay, what else? STP might also be supported. So the building access layer provides important services such as broadcast suppression, protocol filtering, network access, IP multicast, and the quality of service. So for high availability, the access switches are dual attached to the distribution layer switches. So the building access layer might also provide a PoE or the power over Ethernet and auxiliary VLANs to support voice services. Building distribution layer. The building distribution layer aggregates the wiring closets within a building and provides connectivity to the campus core. So it provides aggregation of the access layer networks using multi-layer switching. The building distribution layer performs routing, the quality of service, and access control. So requests for data flow into the multi-layer switches and onward into the campus core layer. Responses follow the reverse path. So redundancy and load balancing with the building access and campus core layer are recommended. For example, in the figure, the building distribution layer has to equal cost path into the campus core. Okay? So that is providing fast failure recovery because each distribution switch maintains a 2 equal cost path in each routing table to every destination network. So if one of the connections to the campus core layer fails, all routes immediately switch over to the remaining path. Campus core layer. So the campus core layer is the core layer of the campus infrastructure module. So within the enterprise campus functional area, this high-performance switched backbone connects the buildings and various parts of the campus. So specifically, this layer interconnects the building distribution layer with the server farm and the enterprise edge modules. So the campus core layer of the campus infrastructure module provides redundant and fast converging connectivity between buildings and with the server farm, okay, and the enterprise edge modules. So it routes and switches traffic as quickly as possible from one module to another. So these modules usually uses a multi-layer switches for high throughput functions with added routing, quality of service, and security features. Server farm module. So basically, the servers are located on this module. So this is a high-capacity centralized server farm module which provides users with internal server resources. So in addition, it typically supports network management services for the enterprise, including monitoring, logging, and troubleshooting, and other common management features from an end-to-end. So the server farm module typically contains internal email and other corporate servers that provide internal users with application, file, print, email, and domain name systems or DNS services. So as shown in the figure here, because access to these servers is vital, as a best practice, they are typically connected to two different switches to enable full redundancy or load sharing. Okay, so moreover, the server farm module switches are cross-connected to the campus core. Okay, so thereby enabling high reliability and availability for all servers in the server farm module. So the network management system performs system logging, network monitoring, and general configuration management functions. So for management purposes, so an out-of-band network connection. So basically that is a network on which no production traffic travels to all network components is recommended. So for locations where an out-of-band network is impossible, so because of geographic or system-related issues maybe, so the network management system uses the production network. So the network management can provide configuration management for nearly all devices in the network. So using a combination of two technologies, okay? So you can use the Cisco iOS routers that can act as terminal servers to provide a dedicated management network segment to console ports on the Cisco devices throughout the enterprise by using a reverse telnet function. Okay, so more extensive management features, software changes, content updates, log and alarm aggregation, and SNMP, or the Simple Network Management Protocol, can be provided through dedicated out-of-band management network segment. Enterprise Campus Guidelines. So we need to follow these guidelines for creating the modules within an enterprise campus functional area. So first, select modules within the campus that act as buildings with access and distribution layers. Second, determine the locations and the number of access switches and their uplinks to distribution layer switches. Okay, so third, select the appropriate distribution layer switches, taking into account the number of access layer switches and end users. So use at least 2 distribution layer switches for redundancy. Fourth, consider 2 uplink connections from each access layer switch to the distribution layer switches. Okay, so step 5, determine where servers are or will be located. So and you have to design the server farm module with at least 2 distribution layer switches that connect all servers. Okay, so that is to eliminate the possibility of downtimes. Sixth, design the campus infrastructure module campus core layer using at least 2 switches and provide for the expected traffic volume between modules. And then the last one would be, of course, you have to interconnect all the modules of the enterprise campus with the campus infrastructure module campus core layer in a redundant manner. Enterprise Edge modules. So this section describes the components of the enterprise edge and explains the importance of each module. So the enterprise edge infrastructure modules aggregates the connectivity from various elements outside the campus. Okay, so using various services and wide area technologies as needed. Okay, so this typically provision from service providers and route the traffic into a campus core layer. So the enterprise edge module perform security functions when enterprise resources connect across public networks and the internet. So as shown in the figure, okay, and in the following list, the enterprise edge functional area is composed of 4 main modules. You've got the e-commerce module, the internet connectivity module, the remote access and VPN module, and you've got the WAN and MAN and site-to-site VPN module. Now, for the e-commerce module, okay, so what it does is, so basically, the e-commerce module includes the devices and services necessary for an organization to provide an e-commerce applications. So the web server should be there, okay? So you also have the internet connectivity module. So the internet connectivity module provides enterprise users with internet access. So that is where your ISP, okay, you should have at least 2 ISPs, okay, so to connect to your internet connectivity module. That is to provide redundancy if one of the ISP accidentally goes down. So third would be the remote access and VPN module. This module terminates VPN traffic and dial-in connections from external users. Okay, and the last one would be the WAN and MAN and site-to-site VPN module, which provides connectivity between remote sites and the central site over various WAN technologies. So frame relay is nearly obsolete. So we have new technologies coming in, and you can use that to connect on this WAN and MAN and site-to-site VPN module. Now, these modules connect to the campus core directly or through an optional edge distribution module. The optional distribution or edge distribution module aggregates the connectivity from various elements at the enterprise edge and routes the traffic into the campus core. Okay. Now, in addition, the edge distribution module acts as a boundary between the enterprise campus and the enterprise edge and is the last line of defense against external attacks. So its structure is similar to that of a building distribution layer. E-commerce module. So the e-commerce module enables enterprises to successfully deploy an e-commerce applications and take advantage of the opportunities of the internet provides. Okay, so the majority of the traffic is initiated external to the enterprise. So all e-commerce transactions pass through a series of intelligent services that provide scalability, security, and high availability within the overall e-commerce network design. So to build a successful e-commerce solution, the following network devices might be included. Okay, so basically you've got the web servers, okay, so act as the primary user interface for an e-commerce navigation. So you might have also an application servers, okay, so which hosts various applications. Database servers, okay, should be there also, which contains the application and transaction information that is the heart of the e-commerce business implementation. And also there should be firewall or firewall routers, okay, so govern communication and provide security between the systems of various users. Also, there should be a network intrusion detection system, or the IPS, the intrusion prevention system. Okay, so which monitors key network segments in the module to detect and respond to attacks against the network. So you could also have the multi-layer switch with IDS or IPS. Okay, so IDS is nearly obsolete. Okay, and mostly nowadays we are using the IPS or the intrusion prevention system, which provides traffic transport and integrated security monitoring. You could also have the host-based intrusion prevention systems deployed on sensitive core application servers and on dedicated appliances to provide real-time reporting and prevention of attacks as an extra layer of defense also. Next would be Internet Connectivity Module. Okay. Now, the Internet Connectivity Module provides internal users with connectivity to Internet services such as HTTP, HTTPS, FTP, or the Simple Mail Transfer Protocol SMTP and DNS. So this module also provides Internet users with access to information published on the enterprise public servers such as HTTP and FTP servers. So internet session initiation is typically from inside the enterprise towards the internet. Okay. So additionally, this module accepts VPN traffic from remote users and remote sites and forwards it to the remote access and VPN module where VPN termination takes place. Okay. So the internet connectivity module is not designed to serve e-commerce applications. So major components used in the internet connectivity module includes the following. So as what I have mentioned earlier, you've got some sort of the SMTP mail servers, okay? This would act as a relay between the internet and the intranet mail servers. You also have the DNS servers. So serves as authoritative external DNS server for the enterprise and relay internal DNS requests to the internet. So also, you've got public servers, for example, the FTP and HTTP or HTTPS, which provide public information about the organization. Each server on the public services segment contains host-based intrusion detection system, or the HIDS, to monitor against any rogue activity at the operating system level and in common server application including HTTP, FTP, and SMTP. Also, you could implement some firewall here. Okay, firewalls or firewall routers. So provide network level protection of resources, provide stateful filtering of traffic, and forward VPN traffic from remote sites and users for terminations. So edge routers provide basic filtering and multi-layer connectivity to the internet. So again, security should be considered on all of these modules here. Remote access and VPN module. So the remote access and VPN module terminates remote access traffic and VPN traffic that the internet connectivity module forwards from remote users and remote sites. So it also uses the internet connectivity module to initiate VPN connections to remote sites. So furthermore, this module terminates a dial-in connection received from the public switch telephone network or the PSTN. Okay, so and after successful authentication, grants dial-in service or user access to the network. So basically, the remote access and VPN module consists of major components like the dial-in access concentrators. You also have the adaptive security appliances or ASA, firewalls, okay, and you've got some sort of NIPS appliances. WAN and MAN and site-to-site VPN module. So the MAN and WAN and site-to-site VPN module uses various WAN technologies, including site-to-site VPNs to route traffic between remote sites and the central site. So in addition, so we could have the list lines, okay, so circuit switch data link technologies like the old frame relay and ATM, which are already obsolete. So this module can use more recent WAN physical layer technologies. Okay, so something like the synchronous optical network or the synchronous digital hierarchy or SDH, cable, DSL, fiber to home, okay, or the fiber, MPLS, and Metro Ethernet. So it could also include wireless and service provider VPNs. So basically, this module incorporates all Cisco devices and even non-Cisco devices that support these WAN technologies and routing access control and quality of service mechanisms. So although security is not a critical when all links are owned by the enterprise, it should be considered in the network design. Okay, so the key point here is the MAN or the metropolitan area network and the WAN or the wide area network and the site-to-site virtual private network module does not include the WAN connections or links. It provides only interfaces to the WAN. Enterprise Edge Guidelines. So you need to follow these guidelines for creating the modules within the Enterprise Edge functional areas. Okay, so first, create the e-commerce module for business-to-business or business-to-customer scenarios. When customers or partners require internet access to business applications and database servers. So deploy a high security policy that allows customers to access predefined servers and services yet restricts all other operations. Okay? So second, you need to determine the connections from the corporate network into the internet and assign them to the internet connectivity module. So this module should implement security to prevent any unauthorized access from the internet to the internal network. So public web servers reside in this module or the e-commerce module. Third is design the remote access and VPN module if the enterprise requires VPN connections or dial-in for accessing the internal network from the outside world. So implement a security policy on this module. Okay, so users should be able to access the internal network directly without authentication and authorization. So the VPN sessions use connectivity from the internet connectivity module. Okay, so next would be determine which part of the edge is used exclusively for permanent connections to remote locations such as branch offices, and assign it to the WAN and MAN and site-to-site VPN module. All WAN devices supporting frame relay, ATM, okay, cable, MPLS, list lines, SONET, SDH, and so on are located here. Service provider modules. So service provider modules, as shown here on this figure, shows the modules within the service provider functional area. The enterprise itself does not implement these modules. However, they are necessary to enable communication with other networks using a variety of WAN technologies and with internet service providers or the ISP. The modules within the service provider functional area are as follows. So basically, you've got the internet service provider module or the ISP module. You've got the PSTN module, okay? And you've got the WAN technology module here. So it could be, again, a newer technology other than frame relay and ATM, which are already obsolete. Now, the internet service provider module. The Internet Service Provider module represents enterprise IP connectivity to an ISP network for basic access to the internet or for enabling enterprise edge services such as those in the e-commerce, okay, remote access and VPN, and internet connectivity modules. So enterprises can connect to 2 or more ISPs to provide redundant connections to the internet. So the physical connection between the ISP and the enterprise can now use any of the WAN technologies available on your work area. Next would be the PSTN module. So the PSTN module represents the dial-up infrastructure for accessing the enterprise network using ISDN, analog and wireless telephony, or the cellular technologies. So enterprises can also use this infrastructure to back up existing WAN links. WAN backup connections are generally established on demand and turned down after the idle timeout. Okay, so next would be this frame relay and ATM module, or shall I call it the WAN technology module. Okay, so the traditional frame relay and ATM are still used by some organization or by some countries. However, despite the module's name, it also represents many modern technologies. That's why I call this the WAN technology module. Okay, so this could include any WAN technology available on your work area. Enterprise remote modules. So the 3 modules supporting remote enterprise locations are the enterprise branch, the enterprise data center, and the enterprise Teleworker. Now, the enterprise branch module extends the enterprise by providing each location with a resilient network architecture with integrated security, communications, and wireless mobility. So any branch office generally accommodates employees who have a compelling reasons to be located away from the central site, such as regional sales office. Okay. Now the branch office is sometimes called the remote site or remote office or maybe sales office. So branch office users must be able to connect to the central site to access company information. Therefore, they benefit from high-speed internet access, VPN connectivity to corporate extranet or intranets, telecommuting capabilities for work at home employees. Okay, you also have video conferencing and economical PSTN quality voice and fax calls over a managed IP networks, or you'll have this VoIP implementation. Okay, so the enterprise branch module is typically, or this one typically uses a simplified version of the campus infrastructure module design. Now let's focus on the enterprise data center module here. The enterprise data center module has an architecture that is similar to campus server farm module as discussed earlier. Okay, so the enterprise data center network architecture allows the network to evolve into a platform that enhances the application, server, and storage solutions and equips organization to manage increased security, cost, and regulatory requirements while providing the ability to respond quickly to changing business environments. So the enterprise data center module may include the following components. So maybe you'll have something like at the interactive service layer and at the management layer. Okay, so take note that at the network infrastructure layer, the gigabit Ethernet, okay, or 10G, or InfiniBand connections with storage switching and optical transport devices. So if you have heard of InfiniBand, that is basically the term used on high-speed switched fabric mesh technology. Okay, so this is used in the storage area network. Now on the interactive services layer, services include storage fabric services, computer services, security services, and application optimization services. Okay, and at the management layer, tools include Fabric Manager. Okay, so for element and network management, or you also have the vFrame for server and service provisioning. So the remote enterprise data center module includes highly available WAN connectivity with business continuance capabilities to integrate it with the rest of the enterprise architecture. So the server farm module in the campus can leverage the WAN connectivity of the campus core, but the remote enterprise data center must implement its own WAN connectivity. Next would be the enterprise teleworker. So enterprise teleworker module provides people in geographically dispersed locations such as home offices or hotels with highly secure access to central site applications and network services. The enterprise teleworker module supports a small office with several employees or home office of a telecommuter. So telecommuters might also be mobile users, people who need to access while traveling or who do not work at a fixed company site. Okay, so depending on the amount of use and the WAN services available, telecommuters working from home tend to use broadband or worst, dial-up services if the broadband is not available. So mobile users tend to access the company network using broadband internet service and the VPN client software on their laptops or via asynchronous dial-up connection through the telephone company. So telecommuters working from home might also use a VPN tunnel gateway router for encrypted data and voice traffic to and from the network. So to summarize, based on the SONA, the Cisco Enterprise Architecture provides a modular enterprise-wide hierarchical approach for providing network infrastructure and services to all the places in the network. Okay, so the Enterprise Campus Infrastructure Module includes the Campus Infrastructure Module and the Server Farm Module. So the Enterprise Edge modules includes the e-commerce module, the internet connectivity module, the remote access and VPN module, and the WAN and MAN and site-to-site modules. So the remote enterprise modules includes the remote branches, data centers, and teleworker.